So now we have a sequence of examples of diagnostic plots. We had introduced 5 diagnostic plots. Here we see always 4 plots at a time. We're leaving out the one where you have to plot against each separate x variable, and that is a lot of work. Let's say the residuals versus the axis. And so I'm just looking here at the other 4. So we have the one that looks at normality, QQ plot. We have the one that looks at constant variance here. We have the plot that looks at outliers. Yeah, student has residuals. And we have the plot that looks at high leverage or outliers in X. So I leave you to answer this question. There are several of these. There's some code, more questions. So more code, more questions, the California star data, and I think I have some more. Yeah, here is the Pittsburgh housing data. So the dependent variable is the price of the house, and the independent variables are number of rooms, lot size, age of the house, number of bathrooms, things like that. So for this particular data, I give you the diagnostic plots of the original regression and then the log transformed price, the diagnostic plots. And you see on this one, on the constant variance plot, we see actually an inverse funnel plot. The variance is decreasing. What this means is that the log transform is too strong a transform for the initial problem. It was increasing, that gives away some answer, and here it's decreasing. So what we need is an intermediate transformation that stabilizes the variance, but not so much that it actually decreases. And this intermediate would be the square root. That's really the only one we have talked about. In between not transforming y to the power of 1 and log transforming, there is square root y to the power of 1/2. We could of course use a different power transformation with a different thing than 1/2, but let's not go there. So, and here we see that this nicely stabilizes the variance. Okay, one other comment is on the last plot I had leverage values that were moderately large. The largest one was around 0.4. I just briefly go back. See 0.4 here. It's not very far from the others, but the absolute magnitude is maybe a little large, I don't know. And just for curiosity, I looked at where is this coming from? And that particular observation had the largest lot size and was one of the 3 youngest houses. In Pittsburgh, houses tend to be very old. I wasn't looking at the suburbs, I was looking at Pittsburgh proper. So it was unusual in that it was young and it had the largest lot size. In addition, it also was the most expensive house. But we know that that has nothing to do with leverage, right? Because most expensive is price, meaning y, and that doesn't affect leverage. All right, so here is an overview over the 5 plots, and we've talked about that. I will leave you with this and the diagnostics right here.